Hey Algebra 1, and thanks for tuning in. Today we're going to look at the second part of Lesson 8.0, and again you do have some guided notes to help you. We are going to be talking a lot about vocabulary today, and then again just practicing how to sketch examples of quadratic equations. So let's go ahead and get started. The first question, or the first definition on your guided notes page, is what a quadratic function is. And that can be written in standard form of y is equal to ax squared plus bx plus c, where a does not equal 0. Yesterday, or the day before, we talked about vertex form. Today you might see some more with standard form. Let's go ahead and pause here so you can write down number 1, and then click play when you're ready for number 2. So next one we're going to talk about is a parabola, and that is just a U-shaped graph of a quadratic function. Again, you saw that in the notes for day 1. You're basically just curving the line instead of having straight lines. Again, let's go ahead and pause here so you can write down number 2 and then click play to go on to the next one. Number 3 is a vertex. This is the lowest point on a parabola that would open up, which would be the minimum, or it could be the highest point on a parabola, and that opens down, which is the maximum. Remember, to find the vertex, you would just do whatever h is, comma, k. Let's go ahead and pause here so you can write down number 3, and once you're done, click play to see number 4. Number 4 talks about your axis of symmetry, and we kind of talked about this in the previous video as well. That's the vertical line that divides the parabola into 2 symmetric parts, and you can always find the axis of symmetry as long as you know what h is equal to. Whatever h is will be your axis of symmetry on the x-axis. Let's go ahead and pause number 4 so you can copy it down, and then when you're ready, click play. Number 5 is the domain, and we have learned this before. Those are all possible x values. The range is all possible y values. So we're going to see some of that today. For number 7, the y-intercept, the parabola will only cross the y-axis at exactly 1 point. And those points will change depending on whatever a or h or k is. The x-intercept can be seen on the graph. The parabola can cross the x-axis at either 0 points, 1 point, or sometimes even 2 points, just depending on how the graph looks. Again, let's go ahead and pause here so you can write down the x-intercept. So what we're going to do now is just sketch examples of the following graphs. I'm going to get you to pause this one first to try it, and then once you're done, click play to check your work. Remember, you can use your study sheet to help you of the different transformations that happen when a, h, and k are all involved. Alright, so what I did first is I just drew a rough sketch of my graph, and I have x minus 2 squared plus 4. So this means that h is equal to 2, k is equal to 4, and a is equal to just a regular 1. Since h is 2 and k is 4, that's going to be my vertex, 2, comma 4, and my axis of symmetry is going to be x is equal to 2. I'm going to go and sketch this graph. So 2, comma 4 means I went to the right 2, and then up 4. So there would be my vertex, and my axis of symmetry is on that x is equal to 2. So it's just a normal U-shaped graph. My domain is going to be all real numbers. And then the range can be equal to 4 or greater. So we're going to say y is greater than or equal to 4 for that one. Okay? The next one we have is 2x squared minus 3. So again, let's pause here so you can figure out what is a, h, and k, graph it, and then tell me the vertex, axis of symmetry, domain, and range. Alright, so by now you kind of realize what a, h, and k were, hopefully. A, this time, is going to be equal to 2. H, there's no h in the parentheses, so that's equal to 0. And then k is equal to that negative 3 at the end. So my vertex is h comma k, or 0, -3. So that means my axis of symmetry is equal to 0 on the x-axis. Let's go ahead and sketch this so we can see what happens. Since there's no h, I don't go to the left or right at all, but I do go down for k. And because, there's my vertex, and because I have a is equal to 2, that means it's a vertical stretch towards the y-axis. So that means it's going to be stretching and looking a lot skinnier as two times. So just kind of a rough estimate here. The domain for this one will still be all real numbers. And the reason because is your x values are going to continue to grow, maybe not at a high rate, but they're still going to grow. Your range can be bigger than or equal to 3. So we're going to say y is greater than or equal to, -3. Okay. Then our last one, let's go ahead and try this one. Again, let's find the values of a, h, and k. Graph it, and then determine the vertex, axis of symmetry, domain, and range. So let's go ahead and pause here so you can try this one, and then click play when you're done. All right. So the first thing I notice is a is equal to -1/2, h is equal to -1, and k is equal to 0. Since h and k are known, I can say my vertex should be at -1, 0, and my axis of symmetry is at -1. Let's go ahead and graph it. Now, my vertex, I'm going to just go to the left 1 and plot it right on that line. And then I need to make sure that I vertical stretch correctly. It is going to be a vertical stretch, vertical shrink towards the x-axis, and it might even look like a bowl, since it's going to be opening up twice as wide. So that one maybe would look similar to this. Okay, so the domain again would be all real numbers. I'm going to put ARN. And then the range can be 0 or less than that. So we're going to say y is less than or equal to 0. Okay, that's going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.